Oh, I'm doing it wrong. When you're done, you can check your answer up here. The last blank should be either towards or away from the side with more gas molecules. When you're checking your answer, let me know if there's anything in here that is causing you any confusion, or if I've done it wrong, because I started out doing it wrong. So there's no guarantee that I didn't do the rest of it wrong. So I came up with another way of explaining why the side with more gas molecules is affected more. And if you look at rate law, say, for example, now it's not perfect because, you know, it doesn't take into consideration any mechanisms or whatever, but let's just say that you have a system where you have A plus B plus C, and those are all gases. And then in the reverse reaction, you've just got D. Okay, so if you have the forward rate, that's going to be equal to K times, let's just assume that this is A times B times C. Okay, assume it is a single step process. Okay. The reverse rate would be K times D. Now, if I decrease the volume to half of its original size, what have I done to all the concentrations? I have doubled them. So if I double the concentration of D, I have doubled the rate, yes? But if I double the concentration of A and B and C, I've doubled, quadrupled, octupled. Yes, because each of them multiplies it by 2. Yeah? So that's why the side with more molecules, the rate is affected more. Don't go and explain it that way, because it's not really technically a very good explanation, because the whole rate thing, it depends on whether you've got an elementary process or a mechanism, right? Any questions on this little section here? We're good? Yes, you've got a question.
So shortest way of explaining that.
Of explaining what? Why you won't need to. Okay? That's what it comes down to, is you won't need to explain why the side with more gas molecules is affected more. I'm not going to ask it of you. AP, I've never seen it, so don't worry about it. All right, decreasing pressure by increasing volume. You guys are going to now do this one. Now, one thing I wanted to point out is when you are talking about gases and you're talking about the number of molecules, you have to explain it in terms of the number, not just molecules, but you have to say the number of gas molecules, okay? Someone in my first period class said to me after they got their test back, they're like, I keep missing like these little details in the quizzes and the tests, and I keep getting off like, half a mark here, 0.25 there. How can I not do that? It's by paying big attention when Ms. Spence says things like, must say gas molecules, the number of gas molecules, not just molecules. So if you've got a highlighter, I would highlight that. If you don't have a highlighter, there's a whole bunch at the back there, right beside the free paper. Okay, feel free to help yourself to one if you would like to. Now, if there are the same number of what kind of molecules? Gas molecules on each side, what will happen to the rate? Both rates are either going to increase or decrease. I should have put that in there. I need to fix that. Fix. That star's for me. Okay. Both rates will increase or decrease if they have the same number of gas molecules, the same amount, equally. And there will be, what's going to happen with the shift? There's going to be no shift because the rates are still equal. They have decreased equally or they've increased equally, so the rates are still equal. We only get shifting if the rates are unequal. So you will see a spike in all of the concentrations as we either squish the container or make the container bigger, but then there's going to be no shift, so you won't see any smooth curves. So what's that going to look like on a graph? Or actually, before we get to the graph, this is how you would explain it in terms of Le Chatelier's principle. You could say the stress was, if we had an increase in pressure by decreasing the volume, the system shifts to the side with, so if we're talking Le Chatelier, the stress was an increase in pressure. What does Le Chatelier say the system wants to do? It wants to bring that pressure back down. How are you going to bring it back down? Will you shift to the side with more gas molecules or fewer gas molecules? You're going to shift to the side with fewer gas molecules, and that will bring the pressure back down. If, on the other hand, you had a decrease in pressure as your stress by increasing the volume, the system will shift to the side with more gas molecules to bring the pressure back up. If there are the same number of gas molecules on each side, then shifting will not be able to counteract the change in pressure. The pressure will stay the same regardless of whether you shift or not. So there will be no shift. So you will see a spike. Actually, we should say you will see spikes. But no shift. So let's graph what happens when we have the same number of gas molecules on each side. So we have a system here where we have H2 plus I2, so that's 2 gas molecules. And over here on the right, we have 2 gas molecules. Our rate diagram, we should have the y-axis labeled rate, x-axis labeled time, and we should have our legend, forward and reverse. If you want to use different colors, you can use different colors, but this saves you having to pull out a different writing utensil. Forward, reverse. And at this time here, volume is increased. So we increase the volume. What happens to our forward rate when we increase the volume? It drops. Same number of particles in a bigger space means fewer collisions. What happens to our reverse rate? It drops as well for the same reason. Bigger space, fewer collisions. Does it drop by more? Does it drop by less or by the same amount? Same amount because we have the same number of gas molecules on each side. So it drops by the same amount. Now remember, shifting happens because rates are unequal. Are our rates unequal? No. So they're just going to go straight across. Again, they just stay equal. Okay, concentration diagram. Here's our concentration. Concentration of H2, I2, HI. And at this time right here, we increase our volume. What happens at that moment in time? Tell your partner, what happens at that moment in time? What happens to concentration of H2? Drops. I2? Drops. HI? Drops. How did I decide by how much they dropped? Remember, for volume pressure ones, we're not trying to be accurate at all. We're just trying to make our graph look reasonable. Okay, so you just drop them a little bit. Okay? They're not going to be, technically they should be proportional to however much there is present, but we're not going to do that because otherwise some of them would end up bottoming out and it would be ugly. What happens to the concentrations at this point? Pardon me? They're lower than before. Do they go up? Do they go down? Do they stay the same? They'll go up like this. Well, first of all, if we think about our reaction, if I am making H2, and what we mean by that is when we say making H2, we mean that we are making H2 faster than we are using it up. So there is a net increase in H2. Don't draw that. We're not ready yet. Don't draw those curves. Those are wrong. Okay? If we are making H2 faster than we are using it up, that means we must be using up HI faster than we are making it. So does it make sense for all three of them to go up? No, you can't have both products and reactants shifting to make, like, where are those extra molecules coming from? So this is not correct. What we do know is that the forward rate and the reverse rate are still equal. So what's going to happen to our concentrations? They're going to stay the same. So you're just going to have, okay, there's no shift.
They all, no matter if woods or lithium, they all drop the same, right?
We have them all drop the same just because it makes our diagram tidy. Technically, if the HI got cut in half, don't draw this, okay, but I'm going to draw the red one. If the HI got cut in half, which is about here, okay, then the I2 should get cut in half because that means we're doubling the volume, which would put the I to about there, and then the H2 would be about there. But do you see how that starts to look really ugly and you can't distinguish the lines from one another, which is why we don't bother with that.
Oh, but it's like a decrease in volume or increase in volume.
We just put them all the same so it looks tidy. It's not because they are all the same. It's just because, no. Because if this one were this much, then this one would go down by this much. But that's ugly, right? I'm like, which line is which? Ah, right? Hard to see. Much easier to just do that. Okay? Yeah. Now, over here, you can see we had this area here, which is our spike. So that is our, and I'm going to put it in quotes as a stress, because as it turns out, it wasn't really a stress because there was no shift. So this was not really a stress. Stresses make the rates unequal, but you will see that spike, okay? And do you notice, if you're changing pressure volume, all of the concentrations either increase or decrease. Was that the case when we changed a concentration? Did we have all three of them change when we just changed a concentration? No. So you should, from looking at a diagram, you should be able to tell me what the stress was. If you looked at this diagram, you would say, the stress was a decrease in HI. Yeah? If you look at this diagram, you should say, all of the concentrations changed. So that must be a change in volume to make every single concentration change. Okay. And now we are moving on to page 51. And let's recall, changing the temperature affects the rate of the endothermic reaction more. So if we heat it up, the endothermic reaction will speed up more. If we cool it down, the endothermic reaction will slow down more. After increasing the temperature in this particular reaction here, so if we increase the temperature, which rate will be faster? The reverse rate, because that's when we increase the temperature, the reverse rate will increase more than the forward rate, because the reverse is the endothermic direction. So the endothermic rate increases more. And the exothermic rate also increases, but the rate increases less. And the Y is explained there. So that means that the reverse rate is faster. So what is being made faster, products or reactants? Reactants. And if we are making reactants faster, which rate are we shifting? We are shifting left. So let's throw this on a rate diagram. Okay, what happens? We have increased the temperature. What happens to our forward rate? Increases. What happened to our reverse rate? It increased more, so up we go. Do, 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 do. So our stress has made the two rates unequal. The system will then shift until what? Yeah, it shifts until the rates are equal once again. So what's going to happen to our reverse rate? It's going to have to decrease, and the forward rate is going to have to increase. And in what fashion do they do so? Yes? Steep, shallow, flat. Steep, shallow, flat. You okay? Steep, shallow, flat. So we have our old equilibrium, we have the stress, we have the shift, then we have our new equilibrium. Our concentration diagram, I should rewrite this equation again, N2 plus 3H2 in equilibrium with 2 NH3 plus kilojoules and it really doesn't matter what order we put these in. Here's our concentration, here's our time. N2, H2, NH3. And at that time, we increase the temperature. Now, let's say you wanted to use the pulley method to predict the direction of the shift. Say we didn't know the direction of the shift. You can actually use it in the same way you would with concentration. You can say, okay, here's my pulley system. All right. And what I am increasing is if I increase temperature, I am in essence increasing the kilojoules. Yeah, because that's our kinetic energy. If we increase temperature, we are increasing the kinetic energy. And so you can say, okay, that means I'm pushing up on this side, which means which direction is the top part of the chain going to go? If this part goes up, then the top part is going to go to the left. Yeah? So you can use that to predict that it is going to the left. And if we are shifting to the left, what are we making? N2 and H2. And what are we using up? We are using up NH3. So once you know the direction of the shift, you know which concentrations should be going up and which ones should be going down. So we are making N2 and it's got a coefficient of 1. So let's have some of that get made. Oh, what happened to our concentrations when we changed the temperature? Like in that instant when we increase the temperature? Nothing. They just move faster. Yes? So do you remember in a concentration diagram, when we change a single concentration, you will see a single spike. When we change the volume, all of the concentrations spike. When you change the temperature, none of the concentrations spike. So H2 should be how much compared to the N2? The change in H2 should be 3 times as much because it's got a coefficient of 3. Yeah. Don't you guys get bored? Like, you could move this class along so much faster, right? Like, I'm like, oh, by how much does it change? You could all just be like, 3, moving along. Okay, there we go. NH3 decreases by 2x. Excellent, thank you. Is good. And for a temperature change, there are no spikes on the concentration diagram. Is good? Yes. Excellent. Oh, look, you get to define Le Chatelier's principle again. Try that. You can start it with if or when. Either one works. Where did you go then? So you should really have 4 parts to it. You should say, we've got a system that is at equilibrium. What happens if we stress it? The system will then shift in order to minimize the stress. So actually, no, it's okay. In the reaction above, the forward reaction, okay, so this reaction here, and here is our heat term. In this reaction, the forward reaction, does it absorb or release heat? The forward reaction releases heat. And the reverse reaction, therefore, must absorb heat. If we decrease the temperature, what have we done to the amount of heat in the system? the heat in the system has decreased or lowered. According to Le Chatelier, the system will shift in the direction that, do we want to release heat or absorb heat? We want to release heat in order to bring the temperature back up. And in this case, that means that the system shifts to the right. No? Release heat? Yeah? So in general, these are just two little things that you can remember for yourself. But remember, you can also use the pulley system for just using kilojoules as kind of like a reactant, right? Or a product. But you can also say, okay, decreasing temperature always favors the exothermic reaction, since it releases heat to bring the temperature back up. Increasing temperature favors the endothermic reaction, since it absorbs heat to bring the temperature back down. Didn't we just do this? Hang on. I suppose we could do a decrease in temperature. Ooh. What I would like you to do right now is I would like you to jot down a Le Chatelier's explanation of what happens when we decrease temperature and explain why. Explain why in terms of Le Chatelier. So if I were marking this, I would be looking for you telling me what the stress is. The stress is a decrease in temperature. I would be looking for you to tell me which way it shifts. So the system shifts. Which way does it shift? If we've got a decrease here, that's going to cause it to shift to the right. Now, why is it doing that? If you said to minimize the stress, that is not specific enough. Okay, you want to say it shifts to the right in order to release heat, to bring the temperature back up. If you were dealing with concentration, you would say it shifts to the whatever direction to make more substance X in order to bring the concentration back up, or something like that. If you were talking about pressure, you would say it shifts to this side because that makes more gas molecules, which will bring the pressure back up. So there's kind of four components to any Le Chatelier's answer there. Try to draw the rate and concentration diagrams yourself. Now, your diagrams don't have to overlap the same way mine do as long as your proportions are correct. Have I done it correctly? Yeah.
I thought for the breaks, where the total reactions also go on. Let me know later.
Endo is affected more. So we would have our forward and our reverse. This is endo, the reverse. So it should decrease more than the forward. Yeah? Endo is affected more. And we're just about out of time, so let's see. What is our homework today? There's going to be a quiz on Thursday. Page 37. Whoa, come back. Where'd you go? What happened? Oh, for God's sake. Oh my God, where did it go? No. It's okay, I'll post it on Teams. I'll find it again. It's gone walkabout. I don't know. So confused. There we are. Okay. Bye. Bye. Hi, how you doing?
I'm good. How are you?
Good.
Great to hear. Is there anything for me to do?
There will be.
Okay.
Yeah. I also brought in, where did I put them? Oh, here they are. Right now? Okay. Luckily it was on Saturday, so I had to, I Listen, where am I supposed to be, Roy?
I do not post the lessons. So if you'd like to make quiz on Wednesday,
It's Neville Longbottom and Southern Guy. I actually played half of it.
So I was also like,
I did recognize that.
yeah, it's who would recognize him?
Whoa. Actually, so I'm like kind of. I'm not Ravenclaw. Like I'm a Ravenclaw. I would say I'm a. Because I've got Ravenclaw.
Well,
I mean,
Right? Oh, so are you? I'm not sure how you want.
No, it's just because I care about
I
it.
would also care about you. I can decide myself to raise him. What I'm saying is not people probably but I want to be.
Yeah, Pops is just like, yeah, I want to be on.
Honestly,
It's underrated. It's just the nice people. You want to be there because that's where all the nice people are.
yes.
Unless you're like that one that's been on the line.
What are you doing?
Why are you
house, bro?
wrong house? I think it should be like,
Oh yeah, I'm just
yeah. I can't believe my brother's not. You got me. Pardon me.
I'm just and I agree.
Yeah, my brother would be a Slytherin. He's very Slytherin. Listen to epic and mystical meanings of fire.
Yeah.
Epic. Yo, I have my earbuds right now. You are listening to it. You know? You got it.
I'm doing your earbuds.
Okay, I'm playing for you the first song after the think about it. Okay. They're on? What did they play? Oh, no.
Don't play anything.
You're not even plugged. Okay. Put them on. Put them on. Her. What the
Jennifer.
Put the headphones on.
Anna have chopsticks. I can't finish
Okay. There's stuff. Actually,
right. You have fun. Make sure you listen to oh man. Okay.
no, why? Why'd you not do that?
Which lunch?
I was in leadership. I usually eat lunch.
And if there's not room for them all at this
Depends on which one.
well, I mean, while they're trying.
Are you guys gonna like jump scare me? I sit alone, so like you're welcome. That's perfect. I see you there. It will only take 2 lunches. It only takes
45 minutes.
Listen.
Are you sure that this is the whole lot? Hour, not even there.
2 hours.
Yeah.
Yeah. That's for
There
your
we go. Chopsticks.
Okay,
No, anyway, I gotta go. I don't want to be late. I've been late so many times for so many
Wait. Can I come on your Guys.
Pardon me? The quiz is about all these words, except
Yeah, we stopped there.
double blank. And those are all on the vocab list that we have. Yeah.
Can I take it?
You want to take the quiz?
Oh, this.
Oh, this paper? Yes, 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 yes. Yeah.
I still just get right? No.
Slivers.
Oh, it's flavor.
Yeah.
No, because I don't. Oh, shut. Yeah, and your face is turning red. I did last night. Oh, shut up. Either your face is red. Yeah, I know. Not like it was not what I thought I was going to say. I was on my side. You don't have to make a grab.
Yeah. Let me find this for you, or
Thank you.
Yeah, that's what I'm saying.
there you go.
The curve.
Okay, sorry for the delay.
That's my listening.
All right, and we are 116117. From last time as well. Wonderful. Okay. Fantastic. 111112. 111112. Okay. Very good. Thank you. And 116 and 17. Fantastic. Thank you very much.
It does.
Hello. All right. Now, hang on. You forgot something. What did you forget?
The line best.
The line. Yes. And better if you spread out your data.
Yeah.
Yeah? It's okay. Don't worry. Okay, that was 10. Hello. All right. Kira, so we've got half of that, and this one still needs to be done. Just, you know what? Omit these data and just use this. Okay, that'll just save you half the work. Okay. That was Kira Bain. There we go. Hello. Very nice. Thank you very much. Okay, Spencer. Here we go. Thank you very much. Excellent. 99, 100, 101, 102. Do you want that on a sticky?
Yeah, sure.
I have like my grades. Yes, please. I love those grades. They're so good.
That's like a Friday, doesn't it?
I know. Well, it is almost. Tomorrow's like a day off.
I'm also going to like a clinic in the morning, so I skip the morning too. So then
Yeah. Okay. You forgot a couple things. Well, that, but also, what did I do with my pens? Pens, pens, pens. Pens, pens, pens. Oh, there they are.
Oh yeah.
And your line.
Oh.
Yeah? Okay. Hello. Excellent. Very, very nice. Hello. Emily, that looks great. Thank you very much. Emily. Hello. Excellent. That looks good. Do you know what you forgot though?
Oh, the title.
Oh, yeah.
Yep. Thank you.
Hello. Excellent. Excellent. Very nice. Thank you, Cody. Hello. This looks wonderful. Thank you very much, Matthew. There we go. Hello. That looks really good. Thank you very much. Zoe Sampson. Hello. That looks brilliant. Thank you so much. Oh, Thursday's homework. That's 111112. 11112. Perfect. Thank you very much. Hello.
Hi.
That looks good. Yeah. Thank you very much, Vivian. All right. Hello, that looks really good.
Quick
Thank you
question.
very much. Yes.
Unbiased is not on the quiz because
Unbiased is not on
okay,
the quiz.
because
Nope,
I think
nope, nope,
we
nope.
saw like I think last time you said cross bias, but you did say
Oh, but I didn't
unbiased.
say unbiased. Yeah, that's what I meant.
Okay,
Yeah,
thank you.
yeah. And that was Miriam. There we go. Yes.
This one.
Yes.
Estimate that.
If you estimate the person who's 210 centimeters, you would need the graph to extend further. Yeah.
But did you like show us how to make it extend?
No, you would just need more paper, more graph paper, and then you would continue drawing your line. Yeah? Okay. Okay, very nice. Thank you so much, Valerie.
I did the homework. I forgot my home.
Okay. Yes, and would you like to borrow my book for today? Just if you need to. And then you can tear out any pages that you use so you have them, okay? Awesome. Thank you very
I have
much.
to do these.
That's okay. Don't worry. You've been away a bit. Yeah.
I'm wondering yesterday. Did I?
I don't have it.
I want to show you.
Yeah, that'd be great.
I drew the other part on
Ryan, do you have your homework? Okay. And Hudson, do you have your homework? No.
Wednesday was
Wednesday. Okay, so Mateo, we are on pages 99, 100. Let's just see what we've got. Now, our test is Friday. If you feel like you're not ready for it on Friday because you've been away for like a week, let me know and we can make an arrangement. 99 and 100.
Oh, nice.
Yeah. Very nice. Okay, and then 101, 102. 102, thank you very much. And then 111, 112. 111 and 112, beautiful. And then 116, 117. Nice. Thank you very much. And your title. Hi. Excellent. This is good. You just forgot your title. Yep. Okay, who am I missing? Is Zoe Watt here today? No, she's not.
Finished.
Wonderful, thank you. Now, just before you go, don't forget your title, okay? And Sophia's away. Hernan is away.
Take on my.
Yeah, yeah.